Everybody, I'm going to talk about parent functions, okay? Parent functions. So hopefully off this video you can understand what a parent function is, and then you'll be able to have the tools to identify parent functions. Okay, so what do we mean by a parent function? Well, the parents are what has certain characteristics, and then they're going to pass on those characteristics to their children, but their children look like their parents. They're just a little different. And the parent functions just, there's like, another way to say this is there are different equations, and these equations have similar properties, okay? So we're gonna have the equation, the graph, a name, and since we have a graph and an equation, we can also make an XY table, okay? F of x equals x, so this is like y equals x. This means that whatever x is what y is. So if x is -2, then y is -2. And you can see that right here. If x is -2, y is -2. If x is -1, y is -1. 0, 0, 1, 1, 2, 2. And when you graph this, it looks like 1, 2, 1, 2. It looks like this. And maybe these are a little small, but you'll see that no matter what you do in this, it turns into a line. Okay? And that's why it's called linear. And this is also our y equals mx plus b form. Now, this is the parent function where b is 0 and m is 1. Okay, so if you can change this, like if you had f of x equals x plus 2, this would be, we don't say child function, but this would be like a child of the parent function. The parent function is this, and this is a derivative of the parent function. This would be like shifting it up this way too. You know what I'm saying? All right, so what's next? Quadratic. If you graph a quadratic, you graph it like this, and then it goes up like this. Actually, that's right there. And all I'm doing is graphing these points right here. And this shape is called a parabola. And it is called a U. So a quadratic has x squared. Notice this is only x. This is x squared. This is always a line. This is always a parabola shape. Okay, so quadratic, linear. Quadratic, linear. They're a little different. All right, so this is now x to the third. So x squared, x to the third is a cubic. This one looks like this, where it kind of goes through the middle and it kind of squiggles. Okay, and then this is the absolute value of x. This absolute value function, if you think about it, no matter what you put in for x, you have to get a positive. So everything is going to be positive, and it's going to look like this. You'll see it tries to go negative, and then it gets bounced right back to the positive. So linear is a line, quadratic is a parabola, cubic is, I guess you just call it squiggly, it's a cubic, and absolute value is a V. This is the square root of x. I guess this got cut off. So this is a square root 1. A square root 1 also has to stay positive, but you can't have a negative value in here. So you can't put in -2, you can't put in -3, you can't put in -4, because there's no way you can take a square root of a negative number and get a real number. So the first number you can put in the domain is 0, and then it's gonna go like this. So it kind of starts here and then it kind of shoots off. And the last one is exponential. And this is where the x is the exponent. And you can kind of pick any number you want. Like typically I say 2, so it might be like 2 to the 1, then 2 to the 2. And the way this works is it goes very small, and then 0, 1, and then it shoots up. 1, 2, and then 2, 4, and it starts out like really small over here, and it just shoots up. And that is an exponential. So, how many are there? There are linear, quadratic, cubic, absolute value, square root, exponential. There's 6. So know these 6. You need to know what the graphs look like. You need to know how to identify them off the equations. You need to know the names. And you need to start getting an idea of how to plug in a table for them. So spend some time this week trying to do that, okay?